So this is turning real things on with the Raspberry Pi Compute Module 4, 480, which is this custom circuit board I made, and LND. So my name is Andy Schroeder, and thank you for coming. I'm going to start with a little bit of background of the motivation of the technology stack that I developed to make it easy to turn real things on with Lightning payments. So I have a hardware stack as well as a software stack. So we'll go through that, and then we'll actually build something simple, and then you can get my contact info if you want to stay in touch. So motivation for the technology stack. So I've been working on using Bitcoin to dispense energy-related materials for quite some time. I developed this in 2013. It was a mobile fuel truck that accepted on-chain payments. It was kind of a kludge. You know, I have a tablet PC, an industrial control system, Ethernet cable going between the two. There's a little Wi-Fi to Ethernet adapter up here. You can see outside of this close-up view, but in this one, there's two cell phones sitting there. It was kind of a Rube Goldberg kind of thing. It just barely worked, but it did. You know, but I wanted to continue to make something a little bit. I don't know how to turn that on. Hold on. Try it again. Okay. Can you hear me? Yep, there you go. Okay. So yeah,
as close as possible.
Yeah, I wanted to make something a little bit more robust, and so I shifted to still a fuel pump, but I started to get a little bit better. It was in like a complete cabinet, you know, everything was wired. There wasn't a couple wireless connections. I started to get into some industrial control wiring, but there's still a problem with this fuel pump. I had to have two relays because it wasn't like the first one wasn't powerful enough to control the fuel pump. So then I had to have like a 12-volt relay and then 120-volt relay. It was just kind of, it worked, but barely enough. This is like, I think, the original Raspberry Pi right here. And there's something on top called a GRPC board, which is basically something that has like some amplifiers in it that can amplify the digital output from the Raspberry Pi just enough to power this green relay. And then once I got the green relay powered, then I could power the bigger white relay in the back. This GRPC board thing, it just has a bunch of push pins on it, so like they can pop off. That doesn't really work in industrial environments. And there's like a bunch of different ones that you have to have like a map to put them back and forth. They come off when you're assembling it. And then I had two power supplies because some things require 12 volts, some things require 5 volts. It was just kind of like a mess. Then in 2020, I started working on distributed charge, which was charging electric vehicles, Lightning. So I went from liquid fuels with on-chain payments to Lightning with electric vehicles. Things weren't that bad making it work with the Tesla charger. It was a little bit uglier inside of the car, so I published a picture of that. But this basically was able to allow me to control this, this charging unit, and then send invoices through the charge cable to the car. And the card would decode the Lightning invoice and then make an on-chain payment back through the internet to this computer, which is running a Lightning node. And basically, this whole setup here would then control whether the charging was allowed or disallowed through this black box. I wanted something a little bit cleaner than this. There's a lot of kind of prototyping parts here. There's some USB cables, this weird adapter here. There's another CAN bus transceiver floating here. So I'm trying to get things cleaner and more rugged, and kind of plug and play to use Bitcoin and Lightning in the real world with machines in a very automated way. So I started developing a hardware stack, over many years, and kind of surveyed a lot of products out there. And this setup here kind of came on the market in the last 4 years. It's basically something special called a Raspberry Pi Compute Module 4, which is this here. It's got the same CPU and stuff as a Raspberry Pi 4, except it doesn't have the same pinouts and connectors. So, but then you can get a bunch of different carrier boards for it. It's kind of like a motherboard for a Raspberry Pi. And this Tofu came on the market, and it is really nice because it accepts a huge input voltage range for powering it, 7.5 to 28 volts DC, so you can run it off solar panels, you can run it off a car battery, you can run it off 24-volt industrial control systems, and it automatically regulates that wide voltage range to the 5 volts, 3.3 volts needed.
Sorry, it's me. It'll be back in a second. There it is.
Make sure. Wait for resolution still.
Just good, you're up.
Great. Yeah, so it basically it makes sure that the Raspberry Pi gets the 5 volt and 3.3 volt stable voltages it needs. But the other really awesome thing about this thing is it has an M.2 socket on the back, so you can put a small SSD if you want to use it for a Bitcoin node. You can also put a cellular radio, which is really important for me for things out in the field where you want to be able to connect to the Lightning network or a Lightning node. And so this is hardwired radio, not some mobile hotspot that you're doing a Wi-Fi connection with. It's got some standard antenna connectors, which then allow you to connect to a lot of different readily available antennas. So I discovered this thing, and then there's kind of the mess of wires in here. I was trying to consolidate, and so that's when. This is just a configuration if you want to use it as a Bitcoin node with like a screen. So Raspberry Blitz I had running on here. And so there's this GPIO header that the Raspberry Pi has on it. See it up here in this picture. It's basically a 40-pin header. It's really kind of what makes the Raspberry Pi special because it provides a lot of inputs and outputs that you can do cool stuff with. And so I basically, I'm jumping ahead of myself. I basically designed this board here. It's called board 80, and it revolves around the Raspberry Pi to provide a lot of the connectivity that you need to control and communicate with machines to turn them off and on with Lightning. So some people kind of criticize the Raspberry Pi in the Bitcoin community. It's too expensive. It doesn't have a lot of computing power. We've got other options these days. But the thing that they're missing is this GPIO header that allows all of the connectivity. Like Bitcoiners just running a Bitcoin node don't necessarily appreciate that functionality, so that's why they're kind of frustrated at the high costs of a Raspberry Pi these days. But I think it's not really that bad of an option. And it's cool that you can run all this industrial stuff on the exact same platform as just running a full node. It's like you can have a standardized computing platform for low-end computing. Thanks. And so there's other stuff. There's something called an ESP32. People ask me, why aren't you using that? And the fact of it is, the ESP32 is pretty cheap, but in the grand scheme of things, if you're building something industrial, all the other components around it are actually going to be more expensive than the CPU. And if you just jump from an ESP32 to a Raspberry Pi, it's basically $5 for an ESP32 versus $70 for a Raspberry Pi. You're getting like a full computer. You have an open source operating system. You can run any software on it. So I'm kind of opting for the Raspberry Pi right now, especially because things with Lightning and Bitcoin and machine-to-machine interactions are still kind of early. So I think it's beneficial to have like a more powerful computer to really not limit yourself in what you're trying to do. And then maybe in the next 5 or 10 years, things are going to really optimize in like a lot of really application-specific use cases. But right now, it really helps to have a pretty general-purpose computer. So that's what I've been building around, especially because you can have the cellular on there as well. And I don't think you can get that on the ESP32. Anyway, this device I have, 480, it has like a car connector for connecting to the Tesla charging interface. There's some general-purpose GPIO on some convenient screw terminals. So say you want to build something that maybe you have some big mechanical push button out in the field, or you have a turnstile or something. You want to have some simple on-off input. It's maybe going to trigger a screen to present a QR code, or it's going to say, okay, the person went through such and such gate. You can use these GPIO to hook up to some simple switches out in the field to kind of react to what people are doing to the machines that this could be interacting with. There's a serial console, which I'm going to actually use that right now to connect to this thing, so that we can then bootstrap an internet connection from there. So I'll use that in a minute for a temporary interface with the whole system. There's some reference voltages. That's just a stable 3.3 and 5 volts if you need that for something. Analog inputs. So analog inputs on this little bike here, I'm using an analog input to measure the generator voltage, so you can get some feedback on how your speed versus voltage is happening. So if you want to test drive the bike there that generates satoshis when you generate energy by pedaling it, the analog input will be used for showing that. And what we're going to focus on today are these 4 relays. So these relays allow you to turn things on and off at a much higher power level than the GPIO can do. And in an upcoming slide here, I'm going to talk about really why that's needed. But I have on this little demonstrator here, which is what we're going to be using today, the 4 relays are hooked to there's 4 tiny relays on here, these white things. On here. So we have 4 tiny relays, these are 5-volt relays. There's some fuses there to kind of protect the board. These 4 switches are logic level shifters. So if you want to temporarily kind of like jog your code, you can do it mechanically here by flipping the switch. So it kind of flips the binary level of the switch with that. Then there's the green screw terminals, which are pretty rugged. So these green screw terminals are wired to these big bright relays here that can switch a lot more power, and then they're connected to these plugs. So if somebody has some sort of electrical load, we could plug into one of those for fun here. We could, yeah, that'd be good. We'd have a USB adapter. We can actually turn something on with it. So we'll do that in a minute here. Yeah. There's also a service temperature on here if you want to keep track of whether your equipment's getting hot. So this is kind of how the board fits on top of the compute module carrier board. And now I'm going to talk kind of in detail why the board A0 relays really are needed. So we've got this pink thing kind of represents the Raspberry Pi compute module 4. The green is the GPIO. So GPIO, if anybody's not familiar, it's like a electrical connection on some electronics that you can control as it. Let's plug it in here. Maybe just prop it up against this side here. The GPIO can operate electrically as a digital input or a digital output, and it's typically software controlled, whether it's functioning as an input or an output. And then there's oftentimes GPIOs can have extra functions. The Raspberry Pi, you can also software enable like SPI and I2C and serial on the GPIO instead of making it a simple input and output. So SPI, serial, and I2C, they're basically like really high-speed digital communication protocols that you might want to abstract away from your program. Whereas like a simple digital input or digital output, you're going to explicitly say in your program you're writing, like, turn this on and hold it for a specific amount of time until I say to turn it off. And so what we're going to be doing today is using the GPIO as a digital output, and we're going to control it being on a fixed on position and then a fixed off position. So the GPIOs, if you use them as an output, they output 3.3 volts DC. The maximum is 4 milliamps and 13 milliwatts. So 13 milliwatts is not much output power. So the yellow is board A0, and there's some kind of special stuff in there. I didn't want to draw it all. It's basically like an amplifier with some transistors, but what happens in board A0, it's got the transistor magic, and then this white thing represents the white relays on the board that I pointed out a minute ago. And what happens is it takes the 3.3 volts, 4 milliamps, 13 milliwatts, and boosts it up to 5 volts, 28 milliamps, and 140 milliwatts. Which basically can power the white relay. So the transistors, you have to like hook them up right, and they're like a solid state thing, but the relay is a physical switch, so there's a magnetic field and it causes something to physically move in it. And so it's just like flipping a light switch on one side, but instead of your finger moving it, it's like a magnetic field is causing something to move. So this 5 volts, 20 milliamps, it's enough to move that little switch, and then we can get up to 2 amps of current and 250 volts, which basically allows you to pump 500 watts through board A0. So that's enough to do a lot of stuff, but what I really wanted to do is make a standard 15 amp electrical plug that you used to see on the wall, switchable. So these gray relays are what have been added to do that. So the gray here is another relay. It uses 24 volts, so there's this 24 volt power supply, and then the 24 volt power supply is switched on and off through the small white relays that power the bigger relay. And with this bigger gray relay, we can get 15 amps and 250 volts. So just going from the green GPIO up to this white here through board A0, you can basically amplify by a factor of 38,000 the amount of power that you're able to control with a computer program, which is pretty cool. And with the gray relay that I've added, you're boosting it by quite a bit more. Now, this 500 watts and 2 amps, 250 volts, this could power something much bigger. So like we could turn the power on this entire building off and on with this gray relay if we wanted, if we took this gray relay and replaced it with something to control the whole building, board A0 could do that. So you can really, with board A0, once you get the signal through board A0, you can control a much bigger relay. In this case, we're just doing like a single plug, but we can do a whole building, which is awesome because you can take a lightning payment and make a huge, like, real-world decision with it. Does anybody have any questions so far? I've kind of been rambling here. Is this enough background information, or we're good? So, board A0 in action. I just want to show you a few applications before we start to get into what we're going to do today. So this, I mentioned the Tesla application, so I cleaned that up quite a bit with board A0. And there's like a payment module in the car as well. Cleaned up even more for outdoor application. Wow. And then there's this other stuff over here that's using board A0. So the orange board, there's like an energy buyer and an energy seller. The seller on the orange board regulates whether the power is off and on to the buyer based on whether they are up to date on their payments. And there's two independent meters, so the buyer and the seller can check to see, if everybody's being fair. So it's not trustless because you have to make a little bit of an advance payment because Lightning is like discretized, whereas energy is like an analog flow. So we have some analog and digital mismatch between Bitcoin and energy, but we're pretty well trusted and minimized because the buyer can cut the payment flow off, the seller stops delivering energy. The seller can stop delivering energy if the buyer cuts off the payment flow. And then the little bike here on the other side is another use case. It's got a meter. I said it's using the analog inputs as well. So the meter is connected through board A0. Let me back up and show it. This RS-45 port on the car connector can also be used to hook up to the electric meters. So the orange board has the RS-45 connects to the electric meters, and then it's using some of these relays to control the power off and on. And then the buyer actually has some relays as well because I've got like a time of day sensitive pricing scheme, so the buyer can actually turn electrical loads off automatically if the price is too high for their preference. So they can optimize when they're using electrical loads based on real-time pricing. And so I'm trying to build out a new energy grid that has lightning payments, real-time pricing, and smart loads that can turn off and on based on real decisions. So those are some sort of use cases around board A0. I really built it to be like a general purpose kind of prototyping and early use board. But I think in the next 10 years as this grows, there's going to be sort of more application specific without extra functionality because all of these applications are using a fraction of the total capacity of board A0 because it's flexible, but you may not need everything. So now we're going to talk about the hardware stack that we're going to use, the software stack we're going to use on the hardware stack. So I personally prefer Ubuntu Server just because I'm already using that on my desktop and laptop. So if I go from my normal working environment to this computer here, it's basically the same, all the commands are almost the same. Most people kind of initially started using an operating system called Raspbian on the Raspberry Pi, but I don't really think it's as secure and stable. So I just prefer Ubuntu. And then The 1.22.04, it basically has all the kernel modules required for testing communication, so you don't have to do manual kernel updates. And then 22.04 has WireGuard built into the network manager service. So I'm actually going to use that here in a moment. And the next thing I'm going to talk about is something called StaticWire. It's part of my technology stack. It's a tunneling service that accepts Bitcoin Lightning payments. There's a client that will automatically make payments for the tunneling service. What the tunneling service does is it provides a dedicated public IP version 4, IP version 6 address to any internet connection that supports UDP. And if you don't know what UDP is, any voice or video you're going to be doing over the internet uses UDP, so it's probably not going to be blocked on the internet connection that you're going to tolerate using. It also allows to penetrate through firewalls, network address translation, and it can tolerate dynamic IP addresses. So with this service StaticWire, you can have a machine out in the field with some arbitrary internet connection. You can access it remotely from anywhere with a public IP address, which is really cool. So right now we've got this demonstrator unit. It's actually connected to the Wi-Fi on the orange board. I have a Wi-Fi hotspot there. But the orange board is connected to the internet using cellular. So I've got a cellular connection. It's behind the network address translation on the orange board and the firewall. And what we're going to do with StaticWire is penetrate through that and make a publicly accessible device. If anybody has their laptop here and you want to send me an SSH public key, you can log in, and as we do the demo here, you can test your own program and control the relays and power if you want. So I'll do StaticWire in a minute, but I just wanted to explain what that was. So the other thing we're going to use, there's a Python module called GPIO 0. It's basically a module to set the GPIO pins to output condition, because you have to set whether they're an output or an input, and then set the logic level to high or low, or 0, 1, or on or off, whatever you call it. It's a very simple module, but it's doing a lot of stuff behind the scenes for you. And then we're going to use Lightning Network Daemon. So Lightning Network Daemon has an interface. It's got a GRPC with all their API calls in it. I don't know if anybody's used Lightning Network Daemon, but they've got a pretty comprehensive documentation on their websites, a lot of different subservers, and we're going to use just a few calls for this demo today, but it's enough to get you started. In order to use the Lightning Network Daemon GRPC interface, you need a host name or IP address so you know where to connect to. You have to have an SSL certificate in order to identify, so the server can identify itself to the client. And then there's a macaroon which identifies the client to the server. So I don't have a Lightning node in this room. I have it remotely, so we're going to connect to a remote Lightning node, and that's basically the gRPC server that's running LND. And we're going to use a kind of a URL format to concatenate the hosting, the SSL certificate, and the macaroon into one single string. And there's something called LND connect. And that's what we're going to use. So this is just the LND Connect kind of spec page. It's a really simple spec, but it just basically puts all of the content into a single string that can be easily copied and pasted. So this is kind of a certificate, a macaroon, and a host, and it converts converts it into a long string like this. And umbrella and start9 will give you this string to copy and paste. So it's pretty easy to use from those popular systems. And then we're going to use the Python GRPC client. And there's a number of Python modules that will do the LND GRPC. The one that I'm using is called LND-GRPC-client. And I've actually forked the latest one that I've found. It seems to be kind of like rotating who's modifying that software. It hasn't been modified in 6 months or something, and I added some features and fixed some bugs, so we're going to be using the version that I've forked, basically. The purpose of this LND gRPC client is to assemble the request that you're sending to LND, and then kind of decompose the response that it sends back to you. So, all right, so now we're going to start building. So I'll kind of minimize the slides here. So right now, I have this system. It's connected to the Wi-Fi, but I don't really have a way to log into it necessarily. So what I've done here, I've got a USB to serial adapter, and I plugged it into board A0. So I'm basically using like a 50-year-old communication protocol, a serial port to connect to it. But that's fine. It's going to kind of get the job done for us for right now. So there's this command I'm using. It's just pico turn -b and then the baud rate and then the USB device. And I'm going to use that command, and it's going to basically start a terminal connection over the serial port to the Raspberry Pi compute module that's part of the demonstrator there. So it's just asking me to log in. Okay, so now we're logged into the system, and we can check to see what IP addresses we have. There's basically a Wi-Fi connection, and you can see it's a 10.42.0 address. That's a private, non-routable IP address, so it's basically proving this is on like a Wi-Fi connection that's, you can't connect back into it from a general purpose internet connection. So what we're going to do now is use the StaticWire tunneling service that I mentioned to subscribe to a tunnel that provides us a public address that we can then connect to. So this is another project I have going on called StaticWire, and there's just a few commands you need to run to install it. Trying to make this a little bit simpler, but it's a lot simpler than it could be right now. So we're going to just install as a normal user, so I'm just going to copy and paste these commands here. We're kind of bouncing around the world here with this Wi-Fi cellular. Okay, so we got our package repository list has been updated, so now we're going to actually install the packages needed from the Ubuntu repository. Then let's get these optional tools. Definitely going to enable a firewall here. messed up. Stand by, that messed up. Okay, got the firewall enabled. Check that. There's also a port that I pre-opened for SSH. So once we get this tunnel up, I'm going to disconnect the serial port and do this over the internet from here on out. So we have this other command that actually, so previously I was kind of installing some dependencies, and this command here, this pip command, is actually installing the StaticWire client. So I'm going to go ahead and do that. And it's going to run for a second. Let me check to see what my to-do list here. We got the firewall enabled. Okay. So this is going to download some packages, install the client for StaticWire, and then once I launch the client for StaticWire, it's going to prompt me for a lightning payment. I'm going to pay that, and then it's going to automatically bring up the interface, and then I'll have a public address that then I can connect to from anywhere. So if anybody has a laptop and they want to log in as well, this is just a demo computer, so I'll give you access to it. You can muck around with whatever you want. It would be a lot faster if we were on a different connection at this hotel here. But I just wanted to show that you can do this basically, because it's a real pain point that I've identified with this type of machine in the real world, is getting, like, how do you connect to it? Because cellular is really essential for a lot of these things, and it's a real pain to get a cellular service, a SIM card with a static IP address. Like, cell phone providers just don't want to do that. And I pretty much just gave up and decided to build this tunneling service. It does add another, like, detour on your route through the internet, but the big advantage is, like, you're not exposing any new data publicly that you would otherwise. So the service is like another routing hop. So just like any other internet routing hop, it is like a middleman, but it's at the internet protocol level, not an application level. Proxy or middleman. So it's really a lot better design. You can run any service on it. You can run, even web meetings on it, which is cool. You can host your own Jitsi server, your own web server, whatever you want to host or connect to. You can use this StaticWire service to give yourself or others access to yourself. And you can just move it from any internet connection to another, and it automatically refines itself because it uses the WireGuard protocol, which is pretty much the future of VPN tunnels.
Yeah.
So this is almost done, guys. Just bear with me. Any questions while we're waiting for this to happen? Yeah.
So just to make it clear, you have gotten like just on like if you needed to connect to internet, you could have just used like a Wi-Fi add-on. What you're doing is you're creating your own lightning node and you're trying to make that secure. So that's why it's StaticWire library that you wrote, or
Remote-Is.
So there's actually two big reasons for it. The lightning node is a good one. So like say you want to set up your own personal self-custodial lightning node somewhere, you can do that and use this proxy service to connect to your lightning node, and you can accept incoming channels because your address is public rather than like a private address. But then you can also use it on this type of machines if it's out in the field to access it if you want to monitor it or do like some sort of update, or like the bike right there, it has LN URL running on it to provide the withdrawal. So that web service, LN URL uses a web server that's running on the machine in the bike on this cellular connection, but it's accessible by anyone who wants to connect to, follow the LN URL query. Does that make sense?
so when you say on the field, what do you mean is that it has nothing to do with wherever you reside or a business are connected to. You're talking about having all these devices out there in some farmland, away from civilization, wherever you are, and because of the cell service, the calling card that you're using, you're paying like a cell, you're paying for like a mobile phone plan.
Well, it's kind of so you still need a mobile phone plan for this to work, but it runs over top of the mobile phone plan so that, like, if you try to run a web service on a normal mobile phone plan, you won't be able to connect to it. It won't accept inbound connections.
It's heavily proxy.
What's that?
It's heavily proxy. Mobile network.
Yeah, it's heavily proxied to make it like a private proxy, but what I'm doing is creating a public proxy that's kind of like jumping you out of that private proxy. So we got everything installed. There's a command that we installed with all this. It's called static IP. So I can run that, and there's a few options. I can do add credit, get rental status, get configuration, or auto pay. So if we do get rental status, it's basically going to say that we don't have a account yet. It gives an error. There's no account been set up yet. So what we can do is add credit. And what that's going to do is connect to the rental server, and it's going to present a QR code. There's a pricing scheme here, and I can make a payment, and it's going to rent me a tunnel. So I'm going to scan this QR code with my phone and make a payment.
It's $7 for a month.
What's that?
$7 for a month.
So let me scroll up and I can explain it.
Wow.
It's basically, there's an initial activation fee of 48,000 sats, and then there's a monthly rental of 24,000 sats. So the 48,000 sats, that's kind of like a sunk cost, but what it does do is if you forget to make a payment, I'll reserve your address for up to 2 months. So if you go like a month, if you go like, 50 days without paying, I'll keep your address, but I'm still going to make you back pay for those 50 days to turn it back on. but I won't give the address to somebody else.
As the user of your service, there's no way I can verify you're not selling the metadata, right? As the user of your service, there's not a way for me to know that you're not selling the metadata, right?
Well, I'm no different than any other internet router.
Right.
So anybody else that you're routing data through on the internet could be doing the same thing. So any metadata you want to protect, you should already be protecting it regardless of who you're using. So I did manual pay mode here because I'm trying to make it simple, but I have auto pay mode where it'll automatically pay at whatever frequency based on some pricing threshold. So here I'm manually choosing to pay this 72,000 SAT initial payment, and then within a month I'll have to make a follow-up 24,000 SAT payment to keep it on. But there's an auto pay mode you can test out if you want to use it. That will just, if you leave this thing running, it'll just keep things active, and as long as you don't let the service shut down, you know, it'll be fine, and you have 2 months to turn it back on if you accidentally turn it off. This is not the main point of this talk, though. It's just like a part of my whole technology stack that I created to make it easy to turn things on in the field. So I just paid invoice. It just gave me a error. Let's try this the other day. Okay, fortunately there's a getconf command, we'll run it again. So after we paid, it said there was a payment made, and then they gave the tunnel configuration info. So here's my IP version 4 address, and then I have an IP version 6 subnet. So there's like basically infinity addresses for all intents and purposes available to you on IP version 6. And then this is a WireGuard config file, so somebody's you can actually scan this with the WireGuard app on your phone if you want, but please only now because I don't have to re-rent the tunnel. But you can use this on your phone too if you want to give your phone a static IP address. Let me see if I can run this command again.
Can you increase the font size a little bit?
Oh, sorry, yeah. Do that. Okay, so we got our rental status. We just checked. Zoom in. Is that any better? It's going to wrap it now, but yeah. So I just checked the rental status. I'm going to run the getconf command. I don't know why that thing aired out there.
You're still the slash in the tab? Is that better?
Tested this. That file. So we can manually install the config. It automatically installs it for you, but I don't know what's going on right now.
Yeah, it's too slow.
It's there. I don't know what's up with that.
Perm 9 chmod and some bug.
Yeah, I ran this as root. Maybe I have to.
I love when it does that.
Don't know what's going on here, but I'll have to just do this manually, then we can just install the config file manually. There's a command for that. So figure out what this is about. Well, this will be a tutorial on how to install it manually then if you want. So there's just a command that you can run here. So we got NMCLI connection add type WireGuard interface name WG0 connection name. Actually, that's one more you can import the config file here. Over off the screen, that's what's going on here. Alright, sorry, this terminal emulator is a little wonky. I just built this command up and pasted it in. Okay, sorry. That should be working out. I'll run this command nmcli, so it says our WireGuard connection is established, and we should be able to ping this address from my laptop here, and I'll show you. I am going to be on a cellular connection, Verizon here. And we should be able to ping that. Okay, so we're able to ping this thing now that the WireGuard tunnel's up. Now that the WireGuard tunnel's up, I can SSH into it and I'll have a kind of normal terminal. So here's my SSH command. I just got my private keys file. And we got this IP address that was just rented. So it's asking me to verify the public key fingerprint, which is normal. And now we're in the computer here. You guys get the window truncated a little bit. Projector. Okay. Alright, so we're on, we have a normal terminal. Now we can actually start doing some real control related stuff. So we have the GPIO that I mentioned, ports. So there's a Python module we need for that, GPIO 0. I mentioned that in kind of the intro. So we need to install that module. Let's do that real quick with this pip command. And then after that, we're going to actually just manually run some commands using the IPython shell. I don't know if anybody uses that, but it's a real interactive way to do Python stuff. So I already installed IPython, so I'll just open that up. And we'll import the module. Oh, actually, let me mention something else as well. Let me exit out of here. So you have to be a member of the group GPIO in order to have access to those pins. So I added the account here to the group GPIO. If you don't do that, you have to have group privileges to access that hardware resource. So that's kind of something that can really bite you when you first try to use a Raspberry Pi GPIO, is you don't know why you need root access. Just you're used to having USB ports where you can do whatever you want on it, but this is kind of a more privileged resource. So I imported this module, and now I can create an object for the relay. So there's just this function called LED. So the reason it's called LED is because when people originally started testing this GPIO 0 module, they just had little relays on there because they draw like just a few milliamps, so you can just hook it straight up to the pins. You don't need all these amplification techniques that I've put in here. You can test the outputs working just by looking at the LED. So we'll create this object. We have GPIO 27. Now let me back up and show board A0 kind of a little bit close up. I don't know if you can see it, but we've got the four, there's 8 terminals for the 4 relay outputs. It's kind of behind here. If you guys want to come up and look at the board close up, it's got these things labeled. There's K1, there's K5, K4, K3, K2. K5 is GPIO 27, K4 is GPIO 26, K3 is GPIO 25, and K2 is GPIO 22. We're going to use the top one, GPIO 27, and so that's what we've got in here when we instance the LED object. It's actually an object, not a function. This is kind of a warning message because there's a lot of backends that you can use to use these pins, and it falls back to some default one instead of these others. It's fine. Then the next thing we can do actually is we got this object called relay, okay, and I don't know if you know how to use IPython, but if you put a dot at the end of the object name and press tab, you can see all the properties that it has. So it has one that says is lit. If I look at that, it'll tell me the current state of the output. So it's set to false. Now, one thing I should mention, this LED object, when it's instanced with 27, it sets, when it creates this object, it does the software setting in the hardware to make that GPIO an output, not an input. So the GPIO 0 module does all that magic for you in the background. If you choose another object to instance GPIO 27 with, I think it's called like button or something, you can, it'll automatically instance it as an input. So you can use an input, use a GPIO as an input, and these ones down here are what I intend to use as inputs on this board because they've got their relays to it. But theoretically, you could set one of these relays as an input, it just wouldn't do anything with board A0 installed on the Raspberry Pi. So we've got the relay is not lit, it's basically got the false status. We've got Ellie's lightning LED here plugged in. Now I mentioned these switches on here invert the logic level, so I should be able to turn this switch and where's the wrong one? Okay. I didn't have these plugs labeled. So there's actually an LED on these things, which is nice. That goes on. You can also see the LED on this bigger relay. as well. Then we'll plug this in. It goes on. So I mentioned, a while ago, these switches invert the logic level. So if whatever I have on the computer will invert what's on here, and vice versa. Yeah, it's really nice. So anyway, we'll put it back on off because that's kind of the default. I prefer to have the software logic level to match the hardware, but it's really nice to test things. Because you can separate your hardware electrical wiring from your software components. So the next, so let's check out the properties again for this relay object that we created. So we have, you can blink it, which is not something we want to do. That's just like a software function in the object. We don't want to do that for this case. The main things we want to that I want to use here is on and off. So I can use this on function, and we should be able to turn it on. So now it's on. I can show you here this logic level inversion, this switch. So this is kind of the how to control the hardware part of the talk. And next, we're going to jump into actual lighting stuff. But before that, in order to get an invoice to pay, there's another Python module called QR code _term that I'm going to import. And what that does, you can basically just use a print statement in the QR code string out of the QR code term module. I can just put some arbitrary text here, and it'll give me a QR code in the terminal, so I can do testing of my program without building the GUI first, which is nice. This isn't a lighting invoice, but it's it's a valid QR code. So the next thing we're going to do is set up the Python module GRPC client to connect to the LND node. So there's this other pip command that we're going to run. Actually create a new terminal. I'm going to do that in a new terminal so that we don't lose our my Python environment. So this is going to take a few minutes to install. I want to maybe talk about the next thing. So we're going to import the library once it's installed. And then I mentioned the LND connect string. So that's what this big long thing is. Maybe let's zoom in a little bit. So this is a LND connect URL, so it's prefixed with LND connect. It's got the IP address of my lighting node that's not here. So I've got a lighting node that's up and running already. It's got TCP port, then we got the certificates, and buried in here somewhere. Let me stop like this. The certificate starts here, and then macaroon starts down here. So this thing doesn't give you access to much. I'm not that dumb to give a highly plugged lighting node on the projector. But I wanted to set something up so we can at least test this. Okay, so the GRPC thing's installed. I'm going to switch terminals back. Here. Okay, we're back in IPython. We'll import the module we just installed, and we'll define this string to a variable. Now there's a object that we need to instance from the LND GRPC module. It's called LND client. So we'll pass that object that we're instancing our LND connect string, and then we have this LND object. And with the LND object, we have all the stuff that's in the LND GRPC interface available to use here if we want to scroll through. All this stuff we can do, which is basically what is in this API documentation. So we're going to use the add invoice function here. And I'm going to put this in IPython here. And before I hit the command, I'm going to jump into the documentation and just kind of walk through what we're actually using here. So there's add invoice. The capitalizations are off on the documentation, but it's the same thing. They've got like an underscore and a lowercase module. But basically, it attempts to add an invoice to the invoice database. What it does. This is the way you can manually do all this without the, see all these commands here? This is what we would need to do to do a request and response without the LND GRPC module. So it's kind of saving us a lot of steps. We pretty much got 1, 2, 3, 4 command lines down from all this in this example with that module, which helps a lot if you're doing a lot more complicated stuff. So there's this invoice object that is kind of passed back and forth between the client and the server. There's like a memo, a preimage, an R hash, settle dates, expiry, routings in there, and everything. So I'm going to run the command now. And it basically assigned an invoice to this invoice object that I created. We can see what's in there. So we have all these different properties, and there's a few that we're interested in. One is the R hash. So in LND, when you want to look an invoice back up, you need to pass it the R hash. So this is a string of data that identifies the invoice. I'm going to convert this to a string from binary. I don't remember how to decode this to ASCII. We can do it with this. Actually, hexadecimal. Yeah, this is kind of made the format you might be more familiar looking at it, hexadecimal format. The R hash for the invoice. But the other thing that's really the most important right now, besides the R hash, is the payment address. Which is this one right here. So the payment address, I'm going to convert that one to hex as well. Actually, I think I wanted the payment request. Yeah, I want the payment request, not the payment address. Oh, sorry. So the payment request, this is your Lightning invoice. So this is what's normally passed around. So what we're going to do is use the QR code underscore string function. We're going to pass it the payment request. And it's going to put a QR code on the screen for us. I got to zoom out there. It's not going to let me show the whole thing at that font size. So I I can pay this. But actually, before I do that, I'm going to check the status of the invoice so we can see what that looks like. So there's another thing you can run, LND.lookup_invoice, and back here, you guys. See that? Bottom line? Okay, so we have the invoice, the R hash. So we've got this LND object that we instanced when we gave it our LND connect URL that we use the lookup invoice function. And then we've got the invoice R hash for the invoice that we created. And that populated this outstanding invoice object. Let's see what properties it has. There's kind of an important one here that we're going to look for, which is the property settled. So, we got settled false. So this invoice has not been paid yet. So I can zoom back out here and pay the invoice. Or if somebody else wants to pay it. If you want to try this, make this interactive. You gonna pay it?
Yeah.
Okay, it's only a few usage, so you should be able to afford it for.
Just lists things.
What's that?
Just lists things. I need to scan the graph real quick.
That's a mobile.
Neutrino. Yeah. LND.
Neutrino?
Yeah.
Okay. I paid it.
No.
What's that?
I think I paid it.
Oh, you paid it?
Just those things. Sure.
Okay, so I have to run this lookup invoice again and repopulate the outstanding invoice status variable. So we'll just do that. Let me zoom back in so you guys can see the font. Okay, so we repopulated that, the new value from the server, and then we'll check the settled status, and it says true. So the next thing we're going to do is another step here. We're going to put a little bit of a loop into the mix to see if we can wait for it to automatically be detected. So I'm going to generate a new invoice. That was already been paid. We've got a new invoice. And then I'm going to basically use this little code snippet here at the bottom. We actually need to import the sleep function as well. So we can not overload the CPU. Okay, so now I'll do a while true. We got this. And we're going to check what the value is. And then if it's been received, then we'll make a statement. And then if it's not been settled, then we'll just wait for 1 second and try it again. But I got something. You guys, more hash, not there's two things I messed up here. One, I should have printed the new invoice to a QR code. Do that. Back up. Here's our invoice, new invoice to a QR code. And then now we're going to fix this little bug here. I think this should work. So now we're just waiting. It's checking every 1 second, and then it's waiting for the payment to be made. So I'm just going to back out so we can use this QR code screen. Okay, you want your pay this up? So I'm going to, what do we do when you scan it, then I'll scroll.
Just it.
Okay, so we got payment receipt. So the next thing we need to do is put the control of this relay into the mix. So I'm going to exit out of this IPython terminal. Does anybody have any questions so far? Okay. I'm going to exit out, and we're going to actually just make a file for this. So just test.py, and we're going to go through and I guess I'm going to copy the scrollback buffer. That's what we basically there. So I'm just going to work on this load with okay, so we can get back in there. So first thing we imported was the GPIO 0. We imported our, we defined our relay object. And one thing you actually want to do is initialize to off, because some GPIOs initialize to on when the computer boots up, so you want to start your program off initializing all the outputs to off. Then we imported the QR code, string function, the LND interface. We got to keep this LND connect on here. And I'm actually going to copy and paste this again because it just wrapped it. Great, so I got the main stuff here that we want to do. I'll just clean it up and we can run this. And we can try to turn this thing one swoop with the payment. happens. Okay. I'll put this one on somebody else wants to. What's that? How much sets did I even have on that invoice? Was it 5 or 10?
20.
20. Okay, I'm trying to help you guys. Oh, we forgot to put something in there. Did you pay yet?
Yeah.
Okay, hold on. We forgot the step. We have to put the relay on condition.
Oh, yeah.
Instead of the
After the break.
yeah. It's really here. Now, one thing we might need to do, this might not work, because I think
File,
it's
not, you have to update the file. You're updating it.
yeah, that's one of the two issues. The other thing is, it's likely going to close Python and it might reset that logic level back to off. So I'm going to have to put another sleep statement on here again.
What?
We can try it.
Go ahead.
Well, once the Python interpreter closes, it might
You need a new.
You guys use a more advanced editing system. It's not from 1970. Very quick. I need to put a sleep statement in there at the end because once the Python program quits, it puts the level back off. So we'll just add another.
Oh, like a 10-second delay before the break.
No, just an infinite loop that just holds the program from closing.
Oh.
That way the logic level is held on.
Right.
Because if your script ever crashes, you normally want the default state to be restored to an off position. So that's why it does that. Okay.
Whoa.
Now it's on. So we turn something
Sense
on.
well spent right there.
Oh yeah.
So it works. You can do much more than this chintzy LED with this. And a lot more complicated programs with internet connectivity with this. And I have this screen here. It's basically the same as the other ones. I think we took too much time on this. I don't have like a GUI prepared demo, but if you want to know how to do that. I have a way to do it. I'm not sure if it's the best way. I've been using it, but using TK to do these full screen applications on here. Yeah, we already tried this one a little bit. So yeah, that's pretty much what I had planned. If anybody has any questions, I don't know if I inspired you to make something, but
So when's Elon's first order?
I think based on their history, they don't understand Bitcoin. So,
Right.
I'm not gonna even
Hold your breath.
Can you do Doge?
I don't know what you're talking about. So.
Like, it's obvious to me that it's like very over-engineered for something like this. So I felt
Yes.
you build this specifically, I guess, for your Tesla charging personally, or like your
Any scale.
Anything. Like this could turn off an entire city grid.
But I don't have anything of my own personal
To use it.
like ownership that would use something like this. So it's got to be a very selective, specific market of high power electronics.
Mobile battery packs, like they have them in train stations where you can like rent a charger to like power your phone.
It could be vending machines.
So are you expecting?
Yeah, so this could be used for, so here's some applications. Say you own a self-service car wash.
Yeah.
Instead of dealing with coins, you can use this because, maybe we don't need this thing right here because the car wash has its own and its main, its own automated system. But we can skip this and use the existing relay that's in the car wash, but still use the rest of this. Or maybe you've got a laundromat and you want to make all the washers and dryers except Lightning. You could basically have a kiosk in one corner and you can match the machine number with what you're paying for, and then it controls all the laundry machines. If you have a parking garage gate that you want to open and close.
Vending machines.
Yeah, vending machines. Those are kind of the ones that come to mind. At first to me. But say you have a turnstile in a subway station. Those things are locked. There's some electrical thing that unlocks it so you can spin through. So this can be used for that.
But usually people build like an MVP, and that might just consist of like a ESP32 and a relay, and
What's that?
maybe like a Wi-Fi like add-on to like ESP32. That would be like a minimum viable product.
You mean for like a consumer product?
For any kind of electrical device, my understanding is that if you just have a relay, you can control it with like Raspberry Pi like device. However, yours, like the way that you build it, it's obvious that you like are engineering it for
Something bigger.
higher. Yeah, exactly.
Yeah, well, I wanted to take Lightning to the, I want it to be used for more than just toys.
Yeah.
I want the whole world to be interconnected with this because then it makes Bitcoin more important, and it's going to stabilize the valuation of Bitcoin if our entire economy has it interlocked. That's kind of like, I basically kind of built the toy 10 years ago with, this was kind of my, toy case. And I'm trying to make something that's like what will be used in a factory type environment or another. I want this to be, Bitcoin is going to be big, and I want to help it get there with more rugged setup.
Yeah, this is like an industrialized product, ready. Like, it's not just an MVP, it's got like a super set of features that you get a lot more flexibility there than you're showing off today.
Yeah, and this is totally open. So, you can program this to do whatever you want. That's why I wanted to build it on the Linux platform. A lot of industry uses something called a PLC, but it's proprietary, closed source, and you can't. It's like they've added the internet to it in the last 10 years. This is 10 years old, this thing here. It was a major nuisance getting it to connect to this machine here, and like, it was just not right. It's not secure. Like, we have native security with the Linux operating system. Like, you know, this could be used for more than just lighting stuff. I want to promote a Linux-based control system for all of industry, but Bitcoin is like more interesting than, you know, just doing beat counters. So,
how difficult? Is it fairly simple to put your QR code on that screen?
So I have a QR code on that for withdrawal when you, it's very easy. I mean, if you want to sit down and we can follow through it in like 30 minutes, like I said, it would be it.
Then it would be self-contained, right? And I can pay to have an LED on for 30 seconds.
Yeah.
Just on that.
I mean, we could do that as like a little project the rest of the week if you wanted. I mean, I'll give you SSH access if you want to get into this thing, play around with it.
It is already self-contained. He's in an SSH session, so he's sitting virtually on the board.
Yeah, I'm trying to think if I could launch something on there, but it would be meaningless. I mean, the other three screens are doing it, so it's just a matter of putting the image on there. So, and you can also have a web server running on this. It mirror what's on the, I mean, it's not going to be an exact mirror, but you can mirror the same information in both places. So, one thing that Asher made, that Asher's back there, he's made a web live power monitoring dashboard for the Orange board, and I think we'll probably get that up and running on the projector tomorrow. So, like, the same data that's on the screens in a graphical form with the time history, which is cool. It can come from the same device. I don't think you can do that from the PLC.
Have you talked to any miners who do hosting? Like, could that be an application for, you know,
Which type of miners?
hosted miners?
So hosted miners are kind of interested in this. I mean, I have some communication with some of them. I think it's hard for me to understand the percentage of the market of hosted miners versus, like, you know, self-hosted miners, because these companies are getting big. But it's definitely, I mean, I've heard from a number of them, and I have communication, you know, like I'm updating them on their progress, and it's like, you know, just trying to find a good project to mix it in with. So, anyway, what else? Any other questions? If you don't do anything with electronics, I think you can still take away from this little lightning.
Like the cellular aspect of it.
Yeah.
So you originally made it because the use case was your like a sort of mobile.
This thing?
application? Yeah. Is that why you like have the cellular service?
So that's a big reason. I couldn't really do this demo today without cellular because the Wi-Fi is not stable in here. Cellular wasn't that good either, but it's, I think, better than the Wi-Fi. But the other thing is this Tesla application. So this is a little frustrating, but this goes in the back of the car. It's basically, I call it the payment module for the car, and it needs to remotely connect to your lightning node back at home to make payments. Or I'm not using Neutrino, but you could use Neutrino on here, and that would still need an internet connection. The Tesla has onboard cellular, but it's all totally locked down. So it's easier for me at this point, instead of trying to hack into Tesla's computer system even further, to just add my own secondary cellular. But one thing that I'm also probably going to do is just have a Wi-Fi hotspot built into here, so you don't necessarily need it. But at the same time, one of these things might be placed in a location where there's no wired Ethernet or fiber, so it just adds flexibility to where you can install this.
Thanks, I hate
What's that?
it. Thanks, I hate it. Printers do that, and it's a pain in the ass.
Printers.
Yeah, they have like a consumer-friendly feature where they give off their own Wi-Fi, so you can connect to it to communicate, and it's a pain in the ass in deployment scenarios. That certain ones where Wi-Fi is over too much noise.
You're saying that you can't turn it off.
It's in the way. It messes with your locals.
Well, this is something that
Smaller,
the
it's-
Wi-Fi hotspot can go on only when the charge cable is plugged in. Because it can detect when the cable is inserted. So the way that I would do it on here is when you insert the cable, then the hotspot activates. It has a one-time free-shared key that sends through the data communication on the wire.
I was just thinking always on, but that's nicer. That way it's out of the way. Yeah.
The other thing is, I mean, it's really short range, so 5 gigahertz might be okay, and that's not going to be interfering.
Printers are doing 2.4, 3.
Yeah. So, but yeah, the cellular, I definitely prefer not using cellular because Ethernet is much more stable, but it's just a reality, you know, to be flexible to put the cellular in there. So, you haven't asked any questions. Yeah.
I have to.
I got here a little bit late, to
Okay.
be honest. I apologize.
Thanks for your attention, everybody.